So greetings everyone, my name is Divyanshu.
My name is Aryan.
And today we'll be discussing about a pressing concern in disaster management, cloudburst. So what exactly are cloudbursts? They are meteorological phenomenon characterized by intense and sudden rainfall over a short duration of time. They occur when warm moisture rises rapidly and condenses into clouds. Cloudbursts are highly destructive due to the sheer volume of precipitation and intensity of rainfall, and they can pose life-threatening risks, especially in vulnerable regions. We propose to develop a cloudburst prediction system deployed in an Android app. This app will harness the power of machine learning models and real-time weather data to predict and mitigate the impact of cloudbursts, saving lives and property. There are 4 phases to our project: data collection and integration, model development and training, user interface and alerts, testing, deployment, and collaboration.
So to start with, data collection and integration is basically the kind of data we collect which is used to train our model. So here we have taken particularly 4 locations in northern India where the frequency of cloudbursts is very high, like Shimla, Salon, Leh, Purola. All these are part of Himachal Pradesh and Uttarakhand respectively. Moving on, the data set that we have chosen comprises of 7 independent variables and 2 dependent variables. Like these variables include probability, wind temperature, humidity, and the wind cover, which tells us when the cloudburst is going to actually occur. And now moving on to the model development and the actual algorithm we are using. There are 4 types of algorithm that we are using, which is random forest, gradient boosting, CNN, and linear regression. This is a small snippet of the code of random forest classifier. Random forest classifier is basically an ensemble-based learning which uses multiple decision trees to show the prediction of our model. The accuracy that our model yielded was 90.756%. Gradient boosting is also similar to random forest classifier, but the only issue is that gradient boosting requires more amount of resources which we didn't have at the current time. Hence, we proceeded with RFC. And the accuracy that gradient boosting got us was 89%, which was 1% less than RFC. Now, moving on to the convolutional neural network, we tried to use this model, but the only issue we were facing was CNN is type of a deep learning model which requires the data set to be in images. At current, we didn't have the images, hence we couldn't use this model for our benefit. And linear regression was basically used as a tool to predict whether the cloudburst will happen or not. 0 stands for the cloudburst will not happen, and 1 will it happen or not. These are the topographical images which our CNN model would have used for training, but at the current time we didn't have the images to use for. And these are the final accuracy of 3 of the models that we used. Random forest had 91%, gradient boosting had 89%, and CNN had 82%.
Now coming on to the 3rd phase of our project, these are the 4 screens that our app will present. Starting off with the home screen, you can see the general weather data in your particular location. The 2nd screen shows your general heat map of your location. The 3rd screen shows you about the preventive measures that you should follow during an event of a cloudburst, and we are also including an SOS feature that allows the user to contact emergency services in the case of a cloudburst. So as you can see, this dialog box shows you the intensity of the cloudburst, of whether it will take place or not, and the expected duration it will last for. Now, coming on to the alerts, we are also including a real-time alert system which will alert the user whether the cloudburst is of high intensity, medium, low, or if there's no cloudburst at all. So coming on to the next one, the 4th phase of our project was testing and deployment. We have deployed our app using Firebase, and this is a general snapshot of the code that we have used to deploy our app in Python.
So the target audience of our app will comprise basically of the local residents, the hikers or the tourists who like to visit these places, the researchers, and the business dependent on weather. Like these are the major audience which will be using our app for their welfare as well as for the people around them.
What makes our app unique? So we are focusing on real-time data integration. It will allow the users to have access to whether the cloudburst will take place in real time and update the app in real time. We have used machine learning models which are very accurate in predicting cloudburst models, and it's a very user-centric design, and it's very easy to use for the users in case of an emergency.
So moving on to the last aspect, why did we use app over website? Basically, our major concern was to increase the mobility of the product that we are making. For website, you need to again and again refresh the web page and look and basically carry a laptop as to use all our features. But in app, It's basically a concise version which you can use in the palm of your hand anywhere without any difficulty. And the mobile app has feature which website cannot, that is mobile alerts, that it can give you real-time alerts whether the cloudburst is going to happen or not. The location services basically tracks your location and tells whether there will be a cloudburst or not. And as I said, that the app is better used with faster access. Thank you.
Thank you.